All right, so this is going to be a little bit different, but this is still Algebra 2, but instead of jumping right into the lesson, I'm going to include the warm-up in this video. So go ahead and pause the video now, copy down the warm-up, choose your answer, think carefully, and when you're ready to start again, hit play and I'll go over the solution. But make sure you do give yourself time to write it down and think about it. All right, so you've unpaused me now. And I just want to go through this. So P and Q, they contain sets of numbers. So if that's a little bit hard to understand, think of P, just an example, could be the set of 3 and 4. And then you can think of Q as a set. And you can think of, if every number P is in Q, then Q has to at least include 3 and 4, but it can also include other numbers like 7. So that's your example. All right, so which of the following, and we're looking for something that cannot be true. All right, so 4 is in both P and Q. Well, in my example, 4 is in both P and Q. Can't be A. Let's get B. 5 is in neither P nor Q. Well, that could be true. Look, 5 is right there. It's not in either of those two sets, so it can't be this one. Let's look at C. 6 is in P, but not in Q. So my example needs to be changed a little bit to see if this can happen. So let's change this so that P contains 6, and let's see if Q will not contain it. So if I change this to have 6 included in it now, 5 is still not included, it's not there, it's not there. But by definition, everything that's in P has to be in Q. That's what it said. Every number in P is also in Q. So 6 by definition has to be in the set Q. So this is impossible. 6 is in P but not in Q. It has to be in both of them. So this is the not true one. Remember, we're looking for something that cannot be true. And looking at D, 7 is in Q but not P. Look, 7 is in Q but not P. That is possible. So the correct answer here is C. All right, so continue watching and we'll go on to the lesson. So this is going to be Unit 1, Lesson 3. We are on solving systems of equations by elimination. Once you have this title down, go ahead and write down the standard. That means you do have to flip back to your unit guide. And if you're too lazy, I'll just bring up the unit guide here. Here's our unit guide. All right, we are on, that's the wrong unit guide, Mr. Sindel. All right, I do not know where my unit guide is. So Algebra 2, we're on Unit 1, Unit Guide. All right, so this is a little bit harder to see, so maybe I need to shrink him down. Come on now. That works. All right, so here's our unit guide. We are solving systems of equations by elimination. So we are on Standard D, solving systems of linear equations. All right, Standard D. All right, so this is going to be kind of short notes. I'm going to basically lay out the steps and then do 2 problems with you and we'll be done. So let's just say elimination. Elimination. All right, what do I mean by this? So this is just getting rid of one of the variables. Technically, substitution is a way to get rid of one of the variables, but this is going to be doing it by adding the equations just verbatim, like adding them straight down. So I'm going to list out the steps here, and I'm going to do what I'm doing on the right-hand side for what the steps mean. So 6 easy steps. 6 easy steps. I can write better. Easy steps. And on the right-hand column over here, this is going to be the linear system. That we're trying to solve. All right, so first I want to set up my equation. So my columns are started, although I'm going to give you an equation right here and then we'll continue the column. So here's my problem. So my problem, I'm going to write it over here in my linear system, is going to be 3x plus 2y plus 2y is equal to 7. That's the first one. And here's the second one. Negative 2y minus 2x is equal to 4. I should mention that elimination and substitution are the 2 ways to use algebra to solve. We've learned how to graph to solve. Substitution was a way to use algebra. This is another way to use algebra, just in case substitution looks like it's going to be too hard. In this case, trying to use substitution looks to be a little bit too hard. All right, so what are those 6 easy steps? So I'm going to color code the heck out of this thing. So step number 1. And there are 6 easy steps, so I think that'll fit. Okay. 1 is line up variables. Line up variables. By that, I mean make sure that the x is above the x, the y is above the y. In this case, we don't have that. So let's rearrange everything. We have the commutative property of addition, which just means we're allowed to switch things with, on the same side, and it basically stays the same. So let's have our x's first and our y's second. It doesn't matter. You can choose whichever one you want, but I'm just arbitrarily, I'm randomly choosing. I'm going to do x's first. So 3x plus 2y equals 7. And now I need to rearrange the second equation so that the x comes first. So I want this negative 2x first, the negative 2x, and then the negative 2y, negative 2y. And I'm still equaling to 4. All right, so now that I've lined up the variables, now I'm going to do magic parentheses. So this is going to be step number 2. If I run out of room, I can always go to the next slide. Magic parentheses. The C's. By this, I just mean make parentheses around the entire equations. So instead of just having parentheses around one side of the equation, the entire equation. And then I can make opposites after that. So I'm going to kind of do step 2 and 3 for my linear system at the same time. So I'm just going to do step 3 right here. Step 3 is going to be make opposites. Make opposites. Opposites. And then we'll distribute once we get that set up. So I'm going to set up my system of linear equations. I'm going to write my curly bracket a little bit farther to the left. Give yourself some blank space here and then rewrite your equations. 3x plus 2y equals 7 and negative 2x minus 2y equals 4. Minus 2y equals 4. So let me give you a heads up on what we're trying to do here. So we're trying to basically just add straight down. So don't write this, but we're essentially turning this into an addition problem, and we're adding straight down. 7 plus 4, 11. Equal sign, copy the equal sign. 2y minus 2y, copy that down. 3x plus negative 2x, copy that down. And then we have a combined equation. And hopefully, somehow when we combine the equations, one of these variables is now gone. If that has happened, we have eliminated a variable, and we can solve for that one variable. Right now we can't solve because there are 2 variables, so we're trying to get rid of one. That's our strategy. So in this case, we can just straight on add down and we could get rid of a y. But I want to show you how to use these. So if you just added these straight down, you would be fine. That is a possibility. But I'm going to go and show you how to use magic parentheses to make an opposite. By opposites, I mean I want this x to cancel out. I know that the y's would cancel out if I just added straight down. That's fine. Go ahead and do that. But in this example, I'm going to get rid of the x's. So I'm going to do magic parentheses, which is just put parentheses around the entire equation. All right. And I need to multiply by some number. So what do I need to multiply this number by and this number by so that they both are the same number but opposites? Opposite again means one is a negative and one is a positive. So this is going to be a negative 6 probably, and this is going to be a positive 6. How can I make those both 6 and negative 6? Can you see what to multiply by? The answer is multiply by 2 on the top. You're allowed to multiply by different numbers. So if I multiply by 2 on the top and 3 by the bottom, then this term, when I distribute this 2 times 3x is 6x, and 3 times negative 2x is negative 6x. So they will make an opposite. All right, so I made my opposites by getting the right number. So this is choosing the right number to get your opposite. And then here's step 4. Step 4 is just to distribute. Distribute. If I was being mathematically correct, I would technically multiply the left-hand side by 2 and the right-hand side by 2, but I think this is just a faster way of memorizing it. So this is mathematically incorrect. Maybe someone will be stingy here and say, oh, you should have done it by both sides. But anyway, so I'm going to go ahead and distribute. So again, I'm just copying down that curly brace. So 2 times that 3x. So I can go ahead and I'm going to do this in green so you guys can see what's going on here. 2 times the 3x, that's going to be 6x. Try to do the math before I do it. 2 times 2y, what is that going to be? It's going to be plus 4y. And 2 times this, okay, the arrow kind of went to the wrong space. 2 times the 7. 2 times 7 is 14. And don't forget to copy down that equal sign, equals 14. All right, and then similarly, I'm going to distribute on the bottom. 3 times this negative 2x, that's going to be negative 6x. 3 times this negative 2y, that's going to be negative 6y. And finally, copy down the equal sign. 3 times 4 is 12. All right, now I just need to add straight down, and that is step 5. So step 5 is add down. We'll leave out the straight. Add down. Add down. All right. So by that, and I can even, if you want to do like an invisible little plus mark and then do your line, that's fine. So you can say plus and then do a line straight across. So I'm adding these values now. So I'm going to switch back here to black. 14 plus 12, that is going to be 26. 4y minus 6y, or 4y plus a negative 6y, it's the same thing. That's going to be a negative 2y. Don't forget to copy down the equal sign, Mr. Sindel. There we go. And then I'm going to do 6x plus negative 6x. So technically that's 0x, because a 6 minus a 6, and anything times 0 is just 0, so that just goes away. And I'm left with the equation negative 2y is equal to 26. Wow, that was really easy to solve. So from there, all I need to do is solve for y. So let's do that. When I solve for y, and I guess that's when I add down, I guess it's implied here to solve. So we'll make an asterisk here, solve. So when I solve this, I divide both sides by negative 2 and I get y equals negative 13. I feel like I've made an error in here. Have I made an error somewhere? 2 times, maybe it's just me being paranoid. All right, so moving down, we have y equals 13. Are we done? We are not done, because we need to find the x. We need an x and a y, right? So that brings us to step 6, and I can squeeze it in right here. 6 is plug back in. Plug back in, because you need to put it in for the other variable too. You need to find x. So when I plug back in, and I have run out of room, so I'm going to do step 6 on my next slide. So step 6 on my next slide. So this is going to be, what color was I in? So step 6, this is plug back in. Back in. So we have our y. Our y was y equals negative 13. Y equals negative 13. I need to plug that negative 13 in for the y. Which of these two equations that we started with looks the easiest? And it might be different for you. I don't like negatives personally, so I'm going to plug into this equation. So 3x plus 2y equals 7. Let me rewrite that. 3x plus 2y equals 7. Maybe you like smaller numbers and you'll choose the other one. It'll come out the same. Okay, making sure I copied it down correctly. Now I'm going to plug this value of 13 in for this value of y, because y is negative 13. This y is negative 13. So doing that, I'm still on step 6 here. I have 3x plus 2 times the quantity. Remember, I put parentheses whenever I sub in. Negative 13, and copy down the rest of the equation, equals 7, equals 7. All right, solving here, we have 3x. This is not a plus anymore. This is going to be a minus, because a minus times a positive is a negative. So this is a minus 26 is equal to 7. From here, I'm going to add 26 to both sides. When I add 26 to both sides, I get 3x is equal to 35. Did I add those right? No, I did not. It is 33. Oh, that's a point, I hear someone saying. No, I think I caught it before you did. So, and then once I get 33, I need to divide both sides by 3 to get x isolated, to get x by itself, the letter by itself. When I divide both sides by 3, I get x equals 11. And there's my answer. I'll box my two answers in red. We had a y equals a negative 13 and an x equals 11. So those are the steps, and there's an equation. I'm going to do one more example, and I'm going to do it a little bit faster in case you want that work. And I guess if you wanted to put the solution, another way of writing it, more concise, a little bit shorter, solution, that's how you spell it, would be this. It would be 11 comma negative 13. That's the best way of writing it instead of just leaving them boxed up. But either way is fine with me. So I want to do this example, and it is actually going to be pulled from your homework. So if you can find it in your homework, that's awesome. So this is going to be example 2, example numero dos. And it looks like this, and it is a tough one. So it's going to be 2x minus 7y is equal to 3, and 5x minus 4y is equal to negative 6. All right, so let's go back. Our first step, line up the variables. Are our variables lined up here? X and y, we're good. Step 2, magic parentheses. Magic parentheses, I'm going to put parentheses around all of this, and then I have to figure out how to cancel these out. So both of these have the same sign, a negative and a negative for the y, positive and positive for the x's. That means I'm going to have to multiply one of these by a negative, and I'm not exactly sure what amount I'm going to multiply by. So I'm going to set up my, okay, my pen was lagging there, so it made my curly bracket all weird. My curly bracket, I'm going to put my 2x minus 7. I probably should have just wrote this to begin with out on the right-hand side more to get ready to multiply. 5x minus 4y is equal to negative 6. What am I going to multiply all of the equations by in order to eliminate a variable? So I think the easiest thing is getting rid of these x's. I can see an easy number to multiply by in order to get this number and this number to the same number but opposites. Can you see it? It's technically the least common multiple is usually the easiest thing. And if you remember LCM, the quickest way of doing that is to multiply by the other number. So if I'm trying to get to an LCM that shares 5 from 2, I multiply by 5. And same thing, you just kind of switch them. The 2 goes down here, the 5 goes up here. You flip-flop them. But there's a problem now, and maybe you can see it. When I do 5 times 2x, that's going to be a 10x, and a 2 times 5x, that's going to be a 10x. It's the same number. I want to have an opposite, which means one of them be a negative. So let's just make one of them be a negative. Now I have a 10x and a negative 10x. Perfect. So when I add them straight down, I'm looking in the future. That is going to make it so that the x cancels out. I'm ready to eliminate. So I'm going to go ahead and distribute. When I distribute, I'm going to do all of this in blue. This is going to be 5 times 2x is a 10x. I just did that step right there. And 5 times a negative 7y, that's going to be a negative 35y. A 5 times a 3, right, my equal sign. 5 times a 3 is a 15. All right, now my bottom equation, my last part of my system. Negative 2 times 5x, that's going to be a negative 10x. Hey, look at that. My 10x and negative 10x, those are ready to cancel out. Negative 2 times a negative 4y is a positive 8y. Don't forget that double negative rule. And copy down my equal sign. Negative 2 times a negative 6 is a positive 12. All right, now I just add down. When I add down, I do like adding this little plus and this. Okay, so I'm adding straight down. I can go left to right or right to left. I'll start left this time. A 10x minus a 10x is nothing. It's 0. You can either write 0 or you can just leave it blank. And what now? So a negative 35 plus an 8. Negative 35y plus 8y. What is that going to be? I'll give you a second to calculate. That is going to be a negative 27. Negative 27. Am I right in thinking that? Yeah, negative 27y. All right, and then this is going to be equal to 15 plus 12. That is a 27. Okay, whew, I did my math correct. This has come out to a nice number. You can already see it. If I divide both sides by negative 27, remember I'm dividing by a negative, so this guy will be a negative by its final answer. This is going to be y is equal to -1. All right, so I found one of them. I need to find the other one. I need to find x. So I need to plug this back in to one of these equations and figure out what to do. So when I plug that back in, I'm going to choose the bottom equation because it looks a little bit smaller. I don't want to multiply by 7. I want to multiply by 4. You can choose either one. So I have the original equation. Let me rewrite it, of 5x minus 4y is equal to -6. And I'll plug in -1 in for this value of y right here. And my new equation becomes, I'll just switch to blue again. So 5x minus 4 times, put parentheses around whenever I sub in, -1 equals, copying down the rest of the equation, -6. All right, so simplify this. I have 5x, let's say -4 times -1, that's going to be a +4 equals -6. Subtract 4 from both sides, so subtract 4, I'm left with 5x. Subtract 4 from the right-hand side, that's a -10, because a -6 minus 4 is -10. Divide both sides by 5, and I get x is equal to -2. Box the answer. And my solution is technically -2 comma -1. All right, that concludes the notes. Go ahead and write your summaries. The substitute should have the worksheets for you after your summaries are complete.